All right, we're on to lecture 18, part B. All right, so we're going to do another problem where we try to figure out how much stuff you're going to make in a chemical reaction. And it's going to be a little similar to the last one, although I'm going to show you maybe a little bit different way of doing it in a minute. So typically, like in this example, well, we often might be knowing, oh, we start off with so many grams of one thing. How many grams of something else are you going to make or use up or whatever? So the way you do that, grams of one thing, how many grams of something else are you going to make? You got to go from grams to moles, moles to moles, and then moles back to grams to figure out how much of something else you're going to create. So it takes 3 steps. Step 1, grams to moles. Hey, that's your buddy, the periodic table. Moles of one thing to moles of something else. Oh, I wrote the wrong letter here. Moles of one thing to moles of something else. Oh, that's your coefficients. And then moles back to grams. That's going to be your periodic table again. All right, with that, let's do an example. All right, so here again, we have another reaction, and I say if you use 84.9 grams of C2H5OH, all right, if we use 84.9 grams of this stuff, how many grams of carbon dioxide are you going to make? How many grams of carbon dioxide will you make? All right, so in this example, well, first off, let's think about what we're doing here. That first compound, that C2H3OH, H5OH, this is ethanol. This is actually drinking alcohol. That's the alcohol that's in beer and wine and so on. And what are we doing in this reaction? What kind of reaction is this? What kind of reaction is this? It's a combustion reaction. So a combustion reaction means that it's reacting with oxygen, that alcohol. And if you're burning something that contains carbon, you'll be making carbon dioxide and water. All right, so yeah, this is a combustion reaction. Now, so you're burning alcohol, and I want to know how much carbon dioxide do you make? So burning alcohol, that's actually kind of common in other countries. They use alcohol as a fuel to cook over and so on. So if we burn alcohol, how much CO2 do we make? How do we do that? Grams of alcohol to moles. Moles of alcohol to moles of what I ask you about. Carbon dioxide. And then back to grams. So it's a 3-step problem. You're going to have to bust out your periodic table. You're going to have to use your coefficients. And then you're going to have to use your periodic table again. Let's go over it. All right, so you got 84.9 grams of alcohol. How many moles is that? That's our first step. How many moles? You want to move this over a little bit. How many moles of alcohol is that? All right, so to do that, to get from grams to moles, you got to add up the weights off the periodic table. That's going to be our conversion factor. All right, why don't you practice that? I want you to go ahead and add up what you see in the formula. I'm going to give you a little hint. So you're adding up 2 carbons. Now, the hydrogens, if you look in this compound, there's 5, and then there's another one on the end. So there's actually a total of 6 hydrogens. Why do we write it this way? It has something to do with the order the atoms are connected to each other. That's why it's done this way. But in any case, in total, there are 6 hydrogens, and then there's 1 oxygen. All right, what's the total weight? What's the molar mass for alcohol? Go ahead and add it up. All right, let's see. Let's see if you got it right. So it should be double your carbon, 12. 6 times your hydrogen. And once times your oxygen. The grand total, if you add it up, should add up to, oh, let me work this out a little bit. Oh no, where'd I put my calculator? Shoot. Oh, this is a mess. I just had it. Oh man. Oh, right here it is. Sorry. All right, so I think it's going to be 0.048, but I don't want to mess up. I don't want to make a math mistake. Yeah, 6.048. And then you add 16 to it. And then if you put it all together, the grand total is 46.2 46.068. Now again, 46.068 grams equals a mole. That's what that number means. All right. So let me rewrite it over here just a little bit neater. Now, next thing we got to do is going from grams to moles, you got to decide what to do with the 46. In this case, if I'm starting off with grams, to get rid of grams, you put grams on the bottom. That makes the 46 go on the bottom. And this side, 1 mole goes on top. Now, if you work it out, when I worked it out, I got 1.84 moles. That's what I came up with. All right, so if we've done the first step, we've gone from grams to moles for this beginning compound for, I guess it's alcohol, didn't we say? All right, so right here, we have 1.84 moles. All right, now I'm going to switch. I know all about alcohol. I know how many moles of alcohol I have. I'm going to solve for moles of carbon dioxide. So we'll take that answer, moles of alcohol, and we're going to go to moles of carbon dioxide. All right, just to make this a little cleaner, let's erase this. We're done with that, aren't we? Okay, so that means moles of one thing to moles of something else, it's coefficient time. There's a 2 in front of the carbon dioxide. There is a 1 in front of the alcohol. I'm going to let you think about this. When you are ready to use those coefficients, well, let me say it to you this way. Think about where they go. Are you going to end up multiplying by 2 or are you going to end up dividing by 2? Which one will you do? Multiply by 2 or divide by 2? Oh, I hope you know. I hope you figured out. You got to multiply by 2. All right, so if alcohol is here, you put alcohol on the bottom. And then alcohol's coefficient, which is 1 again. And then you put the coefficient of what I asked you about on top. That's carbon dioxide. So that's why it's multiplied by 2. Whatever you're solving for goes on top, carbon dioxide, and its coefficient, which is a 2. So if we multiply by 2 and divide by 1, the moles of carbon dioxide we're going to make 3.68 moles of it. 3.68 moles of it. All right, one more step to go. We now know how many moles we're going to make. Oh, I miswrote it. Give me a second. We're going to make 3.68 moles. So now let's see how many grams that is. Moles back to grams. It's periodic table time again. All right, so we have 3.68 moles of carbon dioxide. Help me figure out how many grams that is of carbon dioxide. All right, so we got to add up the weight off the periodic table for carbon dioxide. Now, one thing I want to make sure you're clear about, when I say add up the weight off the periodic table for carbon dioxide, because that's going to be your conversion factor to go from grams to moles, you are just going to add up what you see in the formula. So you should be adding up for carbon dioxide 1 carbon and 2 oxygens. What sometimes people do, and it's not right, is you are not, because of that coefficient, you're not adding up 2 carbons and 4 oxygens. So for adding up weights off the periodic table, ignore the coefficients. We already used the coefficient, actually. We used it in the last step. But when I just say, hey, add up the numbers off the periodic table to get me from moles back to grams, just look at the formula, CO2. 1 carbon, 2 oxygens. Now, if we add it all together, when you add them up, it turns out to be 44.01. And oh, that's 44.01 grams equals a mole. All right, we're going to use that down here, moles to grams. What are you going to end up doing with the 44? What are you going to end up doing with the 44? Do you need to get that last step figured out? Do you need to multiply by 44 or divide by 44? Oh, I hope you know. Let's see. I hope you figured this. Oh, you gotta multiply by 44. Okay, you're gonna put 1 mole on the bottom, and the 44 goes on top. Why does that look right to me? Because moles is going to cancel, and we're going to get to grams. So moles goes away, and then we have grams, which is what I wanted. So if you work it out, you should get 162 grams. 162 grams should be the answer. All right, so with that, the right answer is 162 grams. Okay, so I'm going to show you one other thing about a way to do this, which is when I set this problem up, I kind of broke it up into 3 little steps, didn't I? Grams to moles, moles to moles, moles back to grams. I'm going to show you another way of just setting this up. It's going to give you the same answer. It's just another way of thinking it through. All right, so I kind of set it up as 3 little one-step conversion problems. You could, if you want, set it up as one long conversion problem. Which way is right? It doesn't matter. Whatever way you like better, okay? I have to say, if you set it up as one conversion problem, it might be a little faster. All right, let me show you that way of doing it, okay? So I'm going to erase this. And let me show you just another way of kind of showing you the work. All right, we're going to do the exact same 3 steps. Let me just kind of work it out slightly differently. Sorry, I got to erase here. There's no like erase all button on this thing. All right, so you're going to start off. We are starting off. We're doing the same problem. Just showing another way of doing it. With 84.9 grams of alcohol. And I am asking you to solve for, and I might even erase this, grams of carbon dioxide. Okay. Now, if I want to work it out, one way I could do that is I could, instead of doing it like 3 little problems, let's just make it one big problem. We're going to go from grams to moles. We're going to go from moles to moles. We're going to go from moles back to grams. It's going to take 3 steps. All right. So what's the first step? Well, the first step, again, is to go from grams to moles, which means you need to add up the weight off the periodic table. So we did that a minute ago. I'm not going to go bother showing you the work again, but let me just remind you that when we added up the weight off the periodic table for alcohol, we got, oh, let me double check. What did we get? We got 46.068 grams equals a mole. So I could use that in my first step, right? Grams to moles. So you start off with grams, you got to put grams on the bottom, which makes the 46 go on bottom. All right. So if I want, this would be 1 mole of alcohol right here, right? Now, I'm not going to stop. I'm just going to keep on going this time. Another way of showing you the work. So now I'm going to go from moles of alcohol to moles of carbon dioxide. That's your coefficients. The second step is your coefficients. So I would take alcohol, put it on the bottom, put carbon dioxide on top. Now, what are we using here? We're using the coefficients. To get rid of alcohol, you put alcohol's coefficient on the bottom, right there, it's a 1. You put what I'm solving for on top. Carbon dioxide's coefficient, 2 moles of carbon dioxide on top. Now, the last thing we're going to do is we have to go from moles of carbon dioxide to grams. So now we have to go back to grams. So we would need to add up the weight off the periodic table for carbon dioxide. Again, we did that a minute ago when I showed you. Let me go ahead and write it out again. 44, it was 44 grams equals a mole, I think, when we added up carbon dioxide, right? Yeah, I think it was. All right, so now let's see where we're at. We've got grams of alcohol canceling, moles of alcohol canceling. Right now, we've gotten to moles of carbon dioxide. So if you want to finish this thing, you need to get moles to go away. What does that mean? You should put it on the bottom. That makes 1 go on the bottom, and then the 44 go on top. It should look like that. All right, so this is just showing you the same idea as one ginormous conversion factor instead of 3 little conversion problems. All right, So if you work it out, you're going to get the same answer, I promise, 162 grams. Which way is the right way? Doesn't matter, whatever you want to do. All right, so I'm going to stop with this example. We're going to do another one in a minute that's going to be a little bit different. And, you know, if you're still a little shaky on that, that's okay. We're going to see some more examples in our last part of this lecture, okay? Stoichiometry. How much stuff do you make in a reaction? That's what we're doing all today, all right? So that's it for part B. We'll move on to part C in a minute.